This next lesson is kind of just continuing on with that, and it's a little bit of a segue into what's coming next. So we are done with electrochemical cells, and we want to start talking about reverse, which is non-spontaneous reactions. So let's just do a little tiny review on what it means to be a spontaneous reaction. So if you'll recall, anything with an overall cell potential that's greater than 0, the reaction is going to be spontaneous, which means that they will occur without adding energy. If the E value is less than 0 or it's negative, the reaction is not spontaneous or non-spontaneous, but it doesn't mean that a reaction can't occur. What it means is that you would have to put an energy input in to make it occur. Now, the other thing to recall is that when a reaction is reversed, the sign on E is reversed as well, or reverses. Revered. I don't know what I was writing there. Reversed. So only one direction can be spontaneous under the same conditions. So when you put two, like an anode and a cathode together that's spontaneous, it's not like it'll go either way, which is why we've been using one-way arrows. It's that it's only going to go the spontaneous direction. But now we are going to reverse it and make it non-spontaneous. So for example, if I had a cell that had an overall cell potential of negative 0.75, is the reaction spontaneous? No. But if I was to do the reverse of this reaction, so if I switch my anode and my cathode, right, what would be the E for the reverse reaction? Well, it would be positive 0.75, and so then the reverse reaction would be spontaneous. So let's just practice determining spontaneity. So we're just going to look, instead of, I don't know if you remember from a lesson previously, it was like spontaneous or no reaction, which I kept saying is not correct, because it's either spontaneous, non-spontaneous, and no reaction is if you have two reductions or two oxidations. So let's make the differentiation. So I've got these two reactions. Now, what are the reactions in here? Well, this is a balanced acidic redox reaction, but you don't have to work backwards. Don't worry. These are on your sheet. So let's look up our SRP and let's figure out which one is my redox or my reduction reaction and which one's my oxidation reaction. So where is it? So we're looking for N2O4. If you could scream at the screen, that would be awesome. Man, where is it? N2O4. It's funny, I know where my metals are and those kinds of things, but when it comes to these other reactions, I have no idea where they are. Maybe it's further down. Oh dear. Where is it? N2O4. You guys are probably seeing it and just yelling at the screen. I actually had to pause the video to find it. I could not find it. And I don't know if you know why, but I couldn't find it because I was looking for it being reduced. But who knows which one's reduced, right? So maybe I should have found my chromate first and then I would have figured it out. But I finally found my N2O4. So my N2O4 is right here. So this reaction, my half reaction of N2O4 is my oxidation reaction. So if I look at these as two half reactions, the N2O4, and I can write this as balanced or not, it doesn't matter, but is adding to the two waters and forming two nitrates, and 4 hydrogens, and 2 electrons. Now, yes, this whole equation has been multiplied by 3, but that's not going to affect my E value. So my E value, because this is my oxidation, I have to reverse it, and it's going to be negative 0.80. And then my reduction reaction is just going to be my chromium, which is where? Cr3+. Oh, I've lost my ability to find these things. Oh, because maybe I have to scroll. There it is. There it is. So there is my chromium. So I've got my Cr3+. So Cr3+ is going to go, whoops, sorry, add my electrons in there, plus 3 electrons is going to go to chromium solid. Now this is my one that is being reduced, so I'm going to take it as is. So this is going to be my negative 0.74. Okay, Whew. And then again, they had to balance for electrons, so this one got multiplied by 2, but they did all that for you. What we care about is the E value. The E value of this reaction as written is 0.8 plus 0.74, which is negative 1.54, which is not spontaneous. Whereas if I was to reverse it, the E value would be 1.54 and the reverse reaction would be spontaneous. So you're just going to be looking at this as just like a little bit of a reminder and a little bit of an add-on that if the E value is positive, it's spontaneous and you could form an electrochemical cell. And if the E value is negative, it is not spontaneous. And we are going to talk about that next.